I don't know what that means. Good.
Okay, so here's the plan. Unit 1 test Friday. I'm gonna take about half a period and cover absolute value inequalities. Not a big deal. I think you guys have probably seen this at some point before, maybe not in great detail. And then you got the rest of the week, just kind of wrap stuff up. I'll put up an assignment for this, and then you can just work. Tomorrow, how many people have taken TSAT tomorrow? Raise your hand.
Eat, everyone.
That's everybody.
Oh, is that tomorrow?
Yeah.
Oh, boy. I haven't studied.
Okay, so then Thursday we'll have Chromebooks. Just, try to get as much done as you can. Come in and get questions answered on Thursday. I'll put up a practice test that you can practice tests. For those of you who aren't familiar with the way to practice tests, they're not worth anything, but I'll try typically to put up a practice test that's the same as the test, same format, drawn from the same pool of questions. You can do it, just for practice, but it's not actually worth it. You don't have to do it. It's just really there for a resource. Okay, so let's have a look here real quick at a couple absolute value inequalities. So I want to take something like, let's take this top one here. In fact, let's make this one red. How about? And let's make this one green. How about? Green. How about? Okay, and let's graph these. Let's pick some points and let's try to kind of see what these sets look like. Maybe you could even tell me without having to pick points. What does this mean? The absolute value of x is less than or equal to 3. Anybody want to tell me what that means? Say it again, kid. Greater than 0 but less than 3. Okay. Let's graph some points here. Give me an example of some points that would work, that would satisfy this inequality. In other words, that would make it true. That's how we say that in math. Negative 3 would work. So we go back, negative 3. What's another one? 0 would work. What's another one? 3 would work. But negative 2?
Yes.
Positive 2, negative 1, positive 1. Negative 2.99999, etc., right? What about negative 3.1? No. So then the set just looks like that, doesn't it? Excuse me. So what do you think that means then? If I were to say the absolute value of x equals 3, I just would have had the 2 points right there, wouldn't I? So the absolute value of x is really just being described as the distance from, or what that's really describing is just the distance from 0, isn't it? Right? So we've got the set of all points x here such that the distance from the origin is less than or equal to 3. Okay, does that make sense? And so we're going to take this whole range. Here are the endpoints, but it also includes everything in between, right? Now, what if we did something like this? Okay, well, let's just use 3. Use the same number. What if we took the inequality, absolute value of x is greater than 3? By extension, that's going to be the set of all values of x such that, what? The distance from the origin is greater than 3, right? So would, for example, give me a point that would work. 4. 4 would work, right? So we could put a point there, negative 4, right? Would 2 work? No. It's just going to end up being all of the points, in this case, that are further away from the origin, or from 0, than 3, right? Okay. So we're starting to get kind of a picture open up here. When we have an absolute value inequality that uses a less than or a less than or equal to sign, we're talking about an interior interval, right? If we're using a greater than symbol, we're talking about an exterior interval, all the points that are outside of the endpoints, right? Okay. What about something like this? Let's go one step further. What if we try something like this? The absolute value of x minus 4 is less than or equal to 2. Let's just start off and try to see if we can build kind of a visual set of points that work. What's an example of a point that works? 6 works, yeah, okay, so let's try that, 6. Let's see, 1, 2, 3, 4, up with 5, so there's 6. Okay, what else? 4 works. It's another one. What's that one? -2 does not work. -2 minus 4 is -6, and the absolute value of -6 is 6. 3 works. Does 6 work?
I think you're marking the wrong points.
Oh, I am, you're right. I am marking the wrong points. You guys said 5 first, didn't you? And then we said
Well, you also said
4.
6.
And then we said 3. Oh, we said 6, okay. There we go, so we've got those, I think. What about, give me one more integer that works. Which one? 2 works, yeah. And then obviously all of the real numbers in between would work too, right? But the outermost, the furthest we can get away, the widest we can get with this distribution would be from 2 up to 6. Agreed? Okay, and think about if it was just an equation. If it was just an equation, the only 2 points that would work are 2 and 6, right? Okay. So just like before, if we think about the equation first, even if it's not an equation, if we think about the absolute value equation, that's giving us kind of the boundaries of the interval, right? The endpoints of the interval. And in this case, we're looking at all the interior points again, and that makes sense. It's consistent with what we did up here because it's a less than. How do you interpret this, though? What do you think? My question here, and I'm asking a very specific question. I want to know, where do these numbers come into play in that distribution? Do you see the numbers 4 and 2 somehow popping out of this distribution? Oh, okay, good. 4 plus 2 is 6, and 4 minus 2 is 2, right? So 4 is the center of the distribution, isn't it? And 2 is kind of the width of the distribution from center. Call it the spread, right? So this is 2. That make sense? Okay, so anytime that we're dealing with any kind of an inequality where we're taking an x, minus 4. What if it was x plus 4? Where would the center be? -4. Because x plus 4 would just be x minus -4, right? Anytime we've got an expression like this, we're talking about a range of values centered on that number, right? And no further than that far away from it. Make sense? Okay. In other words, the distance between x and 4 has to be less than or equal to 2, right? What if we did something like this? What if we said the absolute value of x minus 3 is greater than 1? What do you think that's going to, how do you think I'm going to draw that one? Where's the center going to be? At 3. Okay, so there's the center. And what's the spread going to be of this distribution? 1. Okay, so there's going to be a point, and there's going to be a point. But now, what does that mean? What's that going to do? If I need the distance between, say it again, it's going to be the outside, isn't it? Because now we want the distance between x and 3 to be more than 1, right? And so if I were to graph this guy, it would look like, that, wouldn't it? Make sense? Okay, so in general, we can say this is always true, right? And this allows us to do something to pretty easily model some, not super complicated physical situations, but we could say, for example, let's say that if we had a 5-pound bag of grapes, and if we looked at all the 5-pound bags of grapes, we found that the 5-pound bags of grapes have an average of 182 grapes. Okay, but there's some variation there. It's plus or minus 6 grapes. could I model that with, if X is the number of grapes in a 5-pound bag, could I model that situation with an absolute value inequality? What'd you do? Gabe, what do you think? What could you do?
It would be X minus 6, right?
Now, remember, the center of the distribution.
Oh, 182.
There you go, minus 182 is what?
Equals.
Well, okay, if we said equals, what's that gonna do? If we said equals 6, then that means we're gonna get, the only values that would work would be 182 plus 6 and 182 minus 6. So what do you think we probably want there? 'Cause realistically, we could have any number of grapes. We could have 183, we could have 181, right? See what I'm saying? So what do you guys think? What's the symbol that should go there? Less than or equal to, probably, right? Less than or equal to 6. And what that's telling us is, we've got this distribution of the number of grapes whose center is at 182, and it's gonna vary up or down from that number by 6. That make sense? Okay. And then if we wanted to, we're gonna talk in a second about how we could turn that into something other than an inequality. Okay? Does that make sense? Okay? So once again, we can always model it. If the variable is X, center of the spread is C, and the width from the center of the distribution is A, call it the spread. All right, so then I want to make an extension of this. You guys told me that, if I go back, you told me that if I do something like this, I end up getting a distribution that's closed on both ends, right? That's an interior distribution. So that means that if I were to write that as an inequality, what would that look like? That red distribution that we graphed. So X is what? X is greater than or equal to 2 and less than or equal to 6. Okay? If we work backwards from that, would you agree that if I were to subtract 2, actually hang on, if I were to, what am I doing here? We're centered on 4. Right, so if I were to want to make this symmetrical, right, about some center point, I could do something like this. I could say X minus 4 is less than or equal. Now, if I'm going to subtract 4 from the middle, what do I have to do to all parts of the compound inequality like this? Subtract 4. So I'm going to get a negative 2, and I'm going to get a 2 there, right? Does that make sense? Okay. Now look what that does. That matches, there's the center of my spread, right? And there's the distribution. Okay, why did I do that? Well, do you think you can make a connection between this absolute value inequality and this compound inequality? What do you think you're always going to do if I start you with something like, you can even make it more complicated. If I start with something like the absolute value of AX plus B is less than C, do you think you could, if I go back and look at that slide again, right? What did we seem to do to get from there? The progression would have been like this, from there to there to there, right? To get from there to there, all I really did right was say that the argument of the absolute value has to be less than or equal to positive 2 and greater than or equal to negative 2, right? The distance between X and 4 has to be pinched between those two positive and negative values, right? And then from there we can do some, we could just add 4 to all parts and come up with our distribution. So what do you think we could do as a general rule whenever we start with an expression like that, where we have an absolute value of some expression in X is less than a number? Remember what we did with the absolute value equations. We always wanted to try to rewrite the absolute value equation as two regular equations, and then we can just do normal algebra. So what do you think? Could I do the inequality equivalent of that? Could I write this absolute value inequality as two regular inequalities, which we would just merge into a compound inequality? Okay. If we know that the value of hand, right, the absolute value of hand has to be less than C, then doesn't that mean that hand would have to be pinched between negative C and positive C? Right? So then couldn't we just rewrite this as the absolute value, oh, not absolute value, sorry. As the expression AX plus B has to be greater than negative C and less than positive C? Right? And now it's just simple algebra to solve for, to solve for X, right? And we'll look at an example or two. Okay. What about, we had something like this. What if we had the absolute value of AX plus B is greater than C? Now, hand would have to be more positive than C, or what? More negative than negative C, right? And that's what we saw when we graphed these things back here. Right? If we had X minus, absolute value of X minus 3 is greater than 1, then X had to be further away from 3 than 1, so we had to spread out sideways. This is an and. The red one is an and inequality, because both conditions have to be met, right? X has to be greater than or equal to 2 and less than or equal to 6, and, right? These are two separate distributions. They can't both be true at the same time. How would I say those, that green pair of intervals? It's got to be or, doesn't it? X is less than 2 or X is greater than 4. It can't be both at the same time. Right? So what am I going to do? What am I going to do here? If hand has to be more positive than C or more negative than negative C, how do I write that? What do you think? How do I say hand is more positive than C? Whatever's behind there has to be greater than C then, right? That has to be true. Or whatever's behind my hand has to be smaller than negative C. And I just treat both of those individually. Right? Okay, so let's try an example. What if I give you something like this? How about absolute value of 2x plus 1 is less than 5. I want to solve that for x. What do I do? It's first step. I have an absolute value of something is less than a number. So I'm just going to automatically make a certain trade. What am I going to do? Drew, what am I going to do there? If I have the absolute value of something is less than a number, that's this guy, right? So then whatever is inside the absolute values goes in the middle, and we do a compound and inequality, right? So what's in the middle has to be pinched between or greater than the negative value and less than the positive value, right? So what about here then? How am I going to rewrite this one? That is what? Greater than? Then negative 5 and less than 5. There you go, right? And we know that because of the direction of the inequality, right? The value has to be less than 5, so it's pinched between 5 and negative 5. Okay. What are the steps I'd go through to solve for x? Subtract 1 from everything, right? That's going to give me negative 6, 2x, and 4. And now what? Divide by 2. And I get negative 3x and 2, right? That's my answer. Okay. How about something like this? What if I have absolute value of 3x minus 2 plus 1 is greater than 11? So what do you think I'm going to do there? Let me do this. Let me do this there. Lily, what do you think I have to do to this one before I can make my trade? It doesn't quite look right yet, does it? It doesn't quite look like we've got a greater than symbol. So we're going to probably use this technique, right? This is going to be our strategy for breaking the absolute value inequality into two regular inequalities. But it doesn't quite look right yet. What do I have to do? Yeah, good. I've got to get the absolute value part by itself first, right? Just like we did with the equation. So if I subtract 1 from both sides, then I'm going to get the absolute value of 3x minus 2 is greater than 10. Now that looks right. Now I've got the absolute value of hand is greater than 10. And so what's that going to be? If I have an absolute value of an expression is greater than a number, is that and or? That's or, right? Okay, so what do I say then? 3x minus 2 is what? Greater than 10. Or is less than negative 10, right? It's got to be extreme. Its value has to be, has to be bigger in the positive or negative direction than 10. So what would I do in this case to solve? Same thing, I'll do them separately, but it's really the same algebra. What are the two steps in order to solve for x? Add 2. So then I end up getting 3x is greater than 12, or 3x is less than negative 8, negative 10 plus 2. Now what? Divide by 3. So I get x is greater than 4, or x is less than negative 8/3. Right? Okay, you gotta be careful about one thing though. Last example, I think you guys can start working on this. I'll answer more questions as you work on it. What if we had something like this? What if we had the absolute value of negative 2x plus 3 is less than 11. Actually, that's not hard. Let's make it. Everybody take a look at that. Think what you're going to do. What's my strategy, first of all? I don't want equals, though. I want less than or equal to. What's going to be my strategy? What do I have to do before I can make my trade for an absolute value inequality? Matthew, what do I have to do for it? Say it again?
Add 1.
Got to add 1, and what else? Divide by 2, good. So I have to isolate the absolute values, and then I can make my trade. So if I add 1 to both sides, divide by 2, you said, right?
Yep.
Now I get the absolute value of negative 2x plus 3 is less than or equal to 11. Okay, now I can make a trade, right? What's my trade gonna be? I've got an absolute value of hand is less than or equal to a number, so is it and or? It's and, okay. So then whatever's in the middle, whatever's in the absolute values goes in the middle. And I'm just gonna do this, right? It's pinched between what values? Negative 11, positive 11. Okay, so now just a little algebra, no big deal, right? Let's see, Alex, what's the first thing I want to do to solve for x here? Here's the x I'm trying to isolate. What do I have to undo?
Isolate.
But how? What do I do to isolate? What's the first step?
Subtract 3.
Subtract 3. Okay, if I do that, I'm going to get negative 14, I'm going to get negative 2x, and I'm going to get positive 8. Now what? Divide by negative 2, you said? Okay, what do I have to be real careful about here? What do I have to do? Yeah, okay. Algebra with inequalities is not hard. They look hard, but I mean, it's the same as it is with equations, except for just a couple instances. There are 2 things you got to remember. And there, eventually there might be some more, but for now there's just 2. If I multiply or divide both sides of an inequality by a negative, I must flip the inequality. Or if I take the reciprocal of an inequality relationship, I have to flip the inequality. Other than that, it's the same. So dividing by a negative means I've got to flip those around, and then what do I end up getting? Negative 14 over negative 2 is positive 7. I get an x in the middle, and I get a negative 4. But these have been reversed, right? So x is greater than or equal to negative 4 and less than or equal to 7. Now, if you put that in Moodle, it'll give you like 80% or something. But what's wrong with that? Yeah, it's in the wrong order. I got to flip it around, right? It's not written in the right format. We always want to write inequalities, compound inequalities like this, like a number line, negative to positive. So we have to put the negative 4 there, the positive 7 there, the x there, and if I flip the whole thing around, it just looks like that. Agreed? Okay? I think you got it. All right. Let's go down to 205.